Dear learners, we are going to discuss today the different aspects of understanding knowledge. Myself is Professor Durga Sankar Rath, Department of Library and Information Science, Vidyasagar University. Today, we are going to explore a fundamental topic which is considered one of the very pertinent aspect in philosophy as well as a branch of philosophy, that is epistemology. Understanding knowledge. Over the next hour, we will take a deep dive into the definition of knowledge, various types of knowledge, its nature, and also its properties. This session will help us to grasp the nuances of what it means to know something and the significance of knowledge in our day to day life, and also the significance of knowledge in the pursuit of education in different academic activities. So, let's begin this intellectual journey together. Now, in this particular session, we are going to unfold the objectives of this particular session. The first objective, we aim to define knowledge and understand its core attributes. This involves unpacking the traditional and modern interpretations of knowledge and how they shape our understanding. So, it's the traditional and modern interpretation of knowledge. The second objective, we are going to cover here the different categories of knowledge. Rather, we would like to classify knowledge into various kinds depending on specific criteria, such as explicit knowledge, tacit knowledge, empirical knowledge, and a priori knowledge. All of these are contributing uniquely to human understanding. In the third aspect we are going to cover here, we will try to delve into the nature and essential properties of knowledge. This includes discussing its dynamic and evolving nature, its dependence on context, and the fundamental properties that validate it as knowledge. What validates it as knowledge? The truth, justification, and belief. So, all these we will cover in the third object, and finally, we will connect these theoretical perspectives into our own domain, that is the field of library and information science. This includes exploring how libraries function as repositories and disseminators of knowledge, and how the principles of information science enable effective organization and retrieval of knowledge. As we know that in library we handle knowledge, we disseminate it So understanding the content is essential for the library professionals. And by the end of this session, all of you should have a comprehensive understanding of these elements, and that will prepare you for deeper exploration and practical application of the concepts that we are going to discuss in next few slides. Now, if we ask ourselves the question, what is knowledge? Answer may be different from different viewpoint, but what is traditionally believed as knowledge is defined as justified true belief. So knowledge, unless it gets justified, we cannot consider it as knowledge, and that is true belief. It plays a crucial role in human thought, action, and society. In all human endeavor, knowledge is essential. To begin, let's define knowledge. What philosophers have long grappled with the question, what is knowledge? And everyone tried to define it in their own way. Knowledge is a term derived from the Greek word gnosis. You see the spelling of it, Gnosis, has always been central to human progress. The quest for knowledge has driven civilizations forward, inspiring technological advancements, cultural developments, and scientific breakthroughs. Philosophically, knowledge is often defined as justified true belief. This means that for something to be considered knowledge, it must be true. You must believe it, and there must be justification or evidence supporting that belief. Beyond the abstract, knowledge also influences our actions and decisions, from the simplest task to complex societal structures. Let's have an example for it. Sun rises in the east. It is the knowledge or true belief that is supported by the fact which is arrived at through daily observations for millions of years by millions of people. However, this definition has been challenged and refined over time, highlighting the complexity of the concept. Because at different point of time, several people might have different interpretation regarding this particular aspect, and they might have challenged it and raised some questions about it. In this context, if we think of our own domain, library and information science, knowledge takes on a practical dimension. Libraries serve as the custodians of human knowledge. We all know that the human civilization, whatever gathered throughout the generations, that have been accumulated together, and we are entrusted with the responsibility as the custodians to handle it, to provide access to the learners, whoever trying to know, whoever has some query regarding this aspect. Organizing and disseminating it effectively with the rise of digital age, managing information efficiently has become even more critical. Efficiently as well as effectively is essential. Knowledge in this field is not just about collecting data but ensuring that it is accessible, reliable, and meaningful for users. So, accumulation only is not the thrust of library and information activities. We have to provide access to those who require the use of them. We have to make them reach conveniently at their fingertip. Understanding knowledge helps information professionals contribute to the essential task of their own, and finally it helps to perpetuate the endeavor of progress in the human civilization. The definition of knowledge varies depending on the perspective. As we have already mentioned, from a philosophical perspective, Plato's classic definition of knowledge as justified true belief. It has been defined none other than the great Plato, and it continues to be a foundational concept in philosophy. It suggests that for something to be knowledge, to become knowledge, it must be true, it must be believed by generations of peoples, and must be supported by justification. While this definition has faced critiques, it provides a starting point for understanding knowledge's conceptual framework. Every aspect must have some critiques. We have to face that, and that is the system of developing knowledge. And from a scientific perspective, knowledge is systematic and evidence based. So, let's see, it's a bit different from the philosophical viewpoint where we have tried to describe it as justified true belief. Now we are talking that it's systematic and evidence based. Systematic in the sense it has some subsystems and each subsystem is related directly or indirectly, and all of them together serve some purpose. It emphasizes observation, experimentation, and validation to build an understanding of the natural and social world. This approach ensures reliability and objectivity, making it essential in advancing human progress. This validation again and experimentation observation aspect reminds us of the spiral of scientific method as propagated by Professor S.R. Ranganathan. In information science, knowledge is seen as an organized and contextualized data. So, it is again from the point of information science, it is organized and contextualized data. This is also another aspect of ICT from the database point of view, how we can make contextualize the data to find out knowledge out of it, to prepare some instruction out of those data. However, modern thinkers emphasize the role of information processing and validation, especially in the age of data and technology. From a practical standpoint, knowledge is not just about possessing facts, It's about applying those facts effectively in real world scenarios. It's not enough to collect information. Organizing it in meaningful ways that allows it to become knowledge. That is, perspective is particularly relevant in library and other information hubs, where the goal is to make data accessible and useful for various stakeholders. To illustrate, consider the difference between information and knowledge in libraries. A catalog of books represents information, but understanding how to navigate and use the catalog to find specific resources reflects knowledge. Many of you might be aware of the existence of catalog, but how to search it, that encompasses knowledge about catalog. This distinction underscores the critical role of knowledge in managing and applying information effectively for any human endeavor. Next aspect is different types of knowledge. Knowledge is not monolithic, it comes in various forms. Explicit knowledge is formalized and easy to share, like a textbook. Tacit knowledge, on the other hand, is deeply personal and experimental, such as knowing how to ride a bike. Empirical knowledge relies on observation and experimentation, forming the bedrock of science. A priori knowledge is rooted in reasoning and logic, independent of sensory experience. Each type enriches our understanding in unique ways. First, explicit knowledge. This is knowledge that is codified, documented, and easy to transfer. Examples include textbooks, manuals, research papers, and recipes. For instance, a computer manual explaining the steps to set up software is a form of explicit knowledge. It is structured and accessible for learning of reference purposes. Implicit knowledge, it is not formally documented but is understood and applied in practical contexts. For example, understanding office culture without it being explicitly stated is implicit knowledge. This type of knowledge is often acquired through observation and experience. Third category is tacit knowledge, which is deeply personal and difficult to articulate. It includes skills and know-how developed through years of practice, such as an artist's intuition for color blending or a surgeon's precision in performing complex operations. Unlike explicit knowledge, tacit knowledge cannot be easily sought and taught through written instructions. Declarative knowledge. Declarative knowledge involves knowing what. It includes facts and information, such as knowing the capital of a country or the historical timeline of events. For example, knowing that water boils at 100 degrees Celsius is declarative knowledge. Procedural knowledge. Procedural knowledge is knowing how to perform tasks or processes. It includes skills such as driving a car, solving math equations, or operating machinery. For instance, knowing how to bake a cake involves procedural steps that need to be followed in sequence. A priori knowledge This type of knowledge is derived from logical reasoning and doesn't require sensory experience. Mathematical truths like 2 plus 2 is equal to 4 or logical statements like all bachelors are unmarried are examples of a priori knowledge. A posteriori knowledge. Posteriori knowledge comes from empirical observation and experience. For example, knowing that ice is cold because you have touched it. It's an example of a posteriori knowledge. It relies on evidence gathered through the senses. Embedded knowledge. Embedded knowledge exists within system, processes, or tools. For instance, knowledge embedded in artificial intelligence algorithms or the workflow of a manufacturing line reflects this type. Embedded knowledge ensures efficiency and consistency in operations. Institutional knowledge, which refers to the collective knowledge specific to an organization or community, it includes historical records, policies, and unwritten norms. For example, a company's best practices and long standing procedures fall under institutional knowledge. Domain experience requires some expertise. So, domain expertise considers another kind of knowledge. It is specialized knowledge in a specific field. A doctor's expertise in diagnosing illness or an architect's understanding of structural design represents domain expertise. This type of knowledge is critical for addressing complex discipline specific challenges. So each of these types of knowledge plays vital role in shaping how individuals and organizations function. By understanding these distinctions, we can better manage, share, and apply knowledge in various contexts. Now, if we come to nature of knowledge, the nature of knowledge is complex and multifaceted. Let's explore its key characteristics. The nature, first, what we can take into account is dynamic and evolving. So, knowledge is always dynamic and it is evolving. It's not static, it changes and grows over time. For example, scientific knowledge evolves as new discoveries are made. What was considered fact decades ago may now be revised or replaced, such as our understanding of the universe's expansion or advancements in medical science. Subjective versus objective. That is another nature of knowledge. It can be both subjective as well as sometimes it is objective also. Subjective knowledge is influenced by personal experiences such as opinions or cultural beliefs, while objective knowledge is based on verifiable facts. For instance, the experience of beauty in art is subjective, whereas the laws of gravity are objective. Next aspect is contextual and domain specific. Knowledge often depends on its context and its specific domain. A software developer's understanding of coding languages is specific to their field, just as a historian's knowledge of a particular era is rooted in its historical context. This specificity highlights the importance of tailoring knowledge to its intended application. Knowledge may be declarative or procedural. Declarative in the sense what about the knowledge, and procedural means how. Declarative knowledge involves understanding facts or concepts such as knowing that water boils at 100 degrees centigrade. Procedural knowledge, on the other hand, involves knowing how to do something like operating a machine or baking a cake. These two aspects often complement each other in practice. Next is collaborative and social in creation and validation. Knowledge is often created and validated through collaboration and social processes. For example, in scientific research, peer review ensures the reliability of findings, while in organizations, team collaboration fosters the development of innovative solutions. Wikipedia is another example where collaborative editing creates a collective repository of information. In the next slide, we are going to discuss the properties of knowledge which make it unique and versatile. Let's examine these properties in detail. Dynamic knowledge is ever changing, influenced by new discoveries and innovations. For instance, our understanding of space has evolved significantly over the past century. Early astronomers believed in a geocentric model, while modern science, fueled by discoveries such as the Hubble telescope, has revealed a vast expanding universe. Intangibility. Unlike physical objects, knowledge cannot be measured or touched. For example, while you can hold a book, the knowledge within the book is intangible. It exists in the content and understanding derived from it, not in its physical form. Perishability. Knowledge can lose its relevance over time as contexts change or new insights emerge. For example, knowledge about outdated programming languages like COBOL has diminished its relevance compared to modern languages like Python or Java. Transferability. Knowledge can be shared through teaching, learning, and communication. For instance, a teacher explaining mathematical concepts to students is transferring procedural and declarative knowledge. Similarly, organizations transfer institutional knowledge through training and documentation to ensure continuity. Theories of knowledge. It's provide framework for understanding how we acquire and validate knowledge. Let's explore three prominent theories with example: empiricism, rationalism, constructivism. Empiricism asserts that knowledge is derived from sensory experience. This means we learn through observation and interaction with the environment. For example, a scientist conducting experiments in a laboratory gathers empirical evidences to support hypotheses. Similarly, a child learns that fire is hot by touching it and experiencing the sensation. Rationalism, it emphasizes the role of reasoning and logic in acquiring knowledge. It suggests that certain truths can be understood without sensory experience. For example, mathematical principles like 2 plus 2 is equal to 4 or logical deductions such as all bachelors are unmarried, these are examples of rationalist knowledge. We can think of different aspects also in rationalism because these truths are considered innate or derived through reasoning. On the other hand, constructivism posits that knowledge is not passively received but actively constructed by individuals based on their experiences and interactions. For example, in education, Students construct their understanding of concepts through group discussions, problem solving, and hands on activities. Constructivism highlights the importance of context and individual interpretation in shaping knowledge. What are the sources of knowledge? Knowledge originates from various sources, each constructive and contributing to how we understand the world. Let's go through the sources with examples. First of all, perception. It involves acquiring knowledge through our senses: sight, sound, touch, taste, smell. For example, you know that an apple is red because you see its color and you understand its taste through experience. Intuition is the ability to grasp knowledge instantly without the need for conscious reasoning. For instance, a chess master might intuitively recognize the best move on the board based on years of experience, even without consciously analyzing every possibility. Testimony: this source relies on receiving knowledge from others, such as teachers, experts, or written accounts. For example, most of what we know about historical events comes from testimony. Books, documentaries, and educators sharing verified accounts. Reasoning: it involves deriving knowledge through logical inference. For example, if all humans are mortal and Socrates is human, then reasoning allows us to conclude that Socrates is mortal. This source emphasizes the importance of critical thinking and structured logic. Memory: it allows us to retain and recall past experiences as a source of knowledge. For instance, you know how to ride a bicycle because you remember the skill from past experience, your practice. Memory is crucial for learning and applying knowledge over time. Experience: practical exposure is a powerful source of knowledge. For example, an intern learns about workplace dynamics through hands on experience. Similarly, traveling to a foreign country provides first and cultural understanding that no textbook can fully convey. Authority: experts' opinions, guidance, they are reliable knowledge, and consulting a doctor, for example, for medical advice or relying on a legal expert for understanding, these basically considered as the authority of their expertise. And whenever we talk on research and exploration, a systematic investigation is essential and study that leads to the generation of new knowledge. Scientific research into renewable energy solutions expands our understanding of sustainable practices. Similarly, archaeological exploration uncovers knowledge about ancient civilization. Knowledge creation process, that is from data to information to knowledge to wisdom, it may be covered in some other areas, but as we can have a quick look, data is the raw unprocessed facts or figures, and in library science a list of book titles and their ISBN numbers represents data. On its own, data lacks context or meaning. Information, on the other hand, organized and given context. Knowledge emerges when information is processed, and of course, examples in library science like cataloging, creating a structured library catalog transforms raw data into an organized system. And finally, we will talk on knowledge representation. Knowledge representation, it's a critical aspect of how information is organized, accessed, and understood. Libraries First, try to classify the knowledge. Classification systems like duodecimal classification, universal decimal classifications, they are used to organize library materials. Then from 000 class of duodecimal classification system to 900 or 999 rather. This systematic arrangement allows users to locate resources efficiently, ensuring that related materials are grouped together. Ontologies and taxonomies, they are frameworks that define relationship between concepts. For instance, in a library database, an ontology might show how Shakespeare relates to drama, Elizabethan literature, historical context, and in taxonomy, hierarchical structures are used to categorize information. For example, a taxonomy of biology might start with broad categories like animals and plants, further dividing into specific groups like mammals, reptiles, flowering plants, and so on. So, there are different examples for practice. In machine readable cataloging repeats knowledge, and also knowledge in the digital age, it has the role of technology that enables the storage of organization and retrieval, digital tools in to facilitate collaborative knowledge, and cloud computing ensures that knowledge can be accessed anywhere. Examples in practice: ebooks, digital repositories, platforms like Kindle, Google Books for ebooks, and digital repositories like Archive. You see the spelling ARXIV, and also DSpace like software are there. Knowledge graphs like Google's knowledge graph organize information into interconnected entities. For example, a search for Albert Einstein not only provides biographical data but also links to related concepts like theory of relativity, physics, Nobel Prize, and so on. And it has several impact in our library activities also. To sum up this, our total deliberation can be categorized into: knowledge is multifaceted and dynamic, understanding its types and nature, and libraries play a pivotal role in organizing this. Here are a few questions for your understanding. What is an example of a explicit knowledge? Answer is, say for example, chemistry textbook, as it is recorded in textbook. And empirical knowledge, observation and experience is empirical knowledge, not testimony, not intuition. And which is following a property of knowledge? Truth is the property, not speculation or perception. And tacit knowledge is context specific and experimental, not derived from observation, or context specific or codified or in manuals. The primary difference between information and knowledge is knowledge is processed and contextualized information, not raw data, while information is processed. And perception as a source of knowledge relies on sensory experiences. Here are a few long questions for you. How does the getter problem challenge traditional epistemology? Explain the difference between empirical and a priori knowledge. Discuss the role of perception, reasoning, and intuition and testimony as sources of knowledge. Which do you think is the most reliable and why? Describe the properties of knowledge. How does the multidisciplinary nature of knowledge contributes to the solving of global challenges such as climate change? In what ways has the digital age transformed the creation, sharing, and validation of knowledge? So, all of these things you might understand about the sharing of knowledge, how knowledge creates, and what are the different properties of knowledge, what is their nature, and all of them will help us to disseminate knowledge among the learners, and thus our library and information science activities will be fulfilled. Thank you.